Welcome to the Stormsurf video surf forecast for the week starting Sunday, February 28th. Looking at significant wave heights for the North Pacific Ocean, we see an area of disturbed weather here just east of the date line, almost in the western Gulf, creating seas aimed somewhat at Hawaii and also at the U.S. West Coast, but nothing particularly impressive. Let's start digging into the details. As usual, we'll start our tour with jet stream level winds. These winds, up about 30,000 feet, help support the formation of gales, and when those gales form, help direct their path. What we're looking for is a trough, that is a dip in the jet, just like what we see here, but this is a rather mild one, a little bit of a trough. What's really more interesting is the consolidated flow of winds coming off Japan, reaching the whole way across the date line to a point north of Hawaii, and even a bit east of there, with winds in the 190 knot range right there. Very solid, very consolidated, and with this dip here, that is, it would support counterclockwise circulation aloft and down at the surface. That is the hallmark of low pressure, and low pressure, of course, generates winds. Winds generate seas. Seas, when they radiate away from the fetch area, turn into swell, and swell, of course, creates surf. So, we see one area favorable for gale development right here in the western Gulf, and that is as of 18Z Sunday. We'll roll this out, and that trough, if anything, builds nice little bit of wind energy here, pushing to 210 knots by Monday night. Very supportive of gale, if not storm development, one would think. And that continues on into about Tuesday night, weakening. And notice the split point. There was a bit of a split in the jet. It's almost pushing to the U.S. West Coast for the first time, maybe all winter. We get into Wednesday night and Thursday, and there it is. Pretty much a consolidated flow moving into Central California. This little bow right here suggests there is still some more split activity to occur. Let's just roll out and see what happens. But no, in fact, it doesn't. The jet remains rather consolidative, 190 knot winds into Friday, and just right on the cusp of wanting to roar onshore into California, but not quite doing it. So we get into Friday night, and then a little bit of an interesting thing develops here over Japan. The jet actually weakens and starts to split. Now, with the active phase of the MJO in play right over this area here, one would not expect that to happen. But in fact, it is forecast to happen. And then, if anything, the jet now still stays reasonably consolidated, but just doesn't have the energy that it did here. Maybe it's just taking a break, or maybe this is a sign of something more to come. Anyway, the jet does reach consolidated into the U.S. West Coast by the latter part of the model run here, out 180 hours, or Sunday night a week out. And the split here is not super pronounced, but definitely there is a lack of consolidated wind energy here off Japan. But consolidated trough pretty much, or a trough in this area, the eastern part of the Pacific, just about the whole week, supportive of storm development. Let's go take a look down at the surface. So here we are, 18Z Sunday, surface pressure, surface winds, and clearly we see a gale, a little bit fragmented here, filling just about the entire middle part of the North Pacific Ocean. Small area fetch here to 45 knot winds, targeting Hawaii well, and then that other little, we noticed it on the significant wave height chart, an area of seas right here, and then also a closed isobar low here, about 972, maybe probably 968 millibars in the western Gulf of Alaska, but very tiny. Anyway, we'll put this into motion, and this one gale up here kind of, maybe I'd just call it a periphery gale. Most of the fetch is right here, 30, 35, almost 40 knots. A little bit of fetch here to 45 knots, targeting Hawaii, and that builds. Now, interesting, previous runs of the model had this fetch here getting very strong, generating high seas, but in the past 2 or 3 runs, that has not been the case. It looks much less impressive than it did. And then also another fetch developing off of North Japan on Monday night. We'll roll this out. We see the gale here in the western Gulf moves into the core of the Gulf, teasing the California coast, but still a light flow as of Wednesday. And then the gale off of North Japan starts basically fading out, but there is fetch over the entire North Pacific Ocean. But if you really look close, it's one pocket of 35 knot west winds there, another there, and 45 knot winds there. Not very consolidated, kind of just spread out and all over the place. Still, all this is good for probably 14, 15-second period swell. For the better part of the week. You just watch this thing go, and there's pulses of energy running through it, all supported by a good jet stream flow aloft. And notice the front just barely here hitting Northern California, but not making any further progress. It's not so much that high pressure here is preventing it, it's that the jet just cannot, for whatever reason, and really we feel it has to do with the westward displacement of El Nino, just cannot make it into mainland USA because the warm water pocket, for the most part, was from about 120 west further out this way and not so much pushed up along the Galapagos and Ecuador. Anyway, we'll roll this out, and the pattern just sort of goes on. Finally, by Sunday, low pressure looks like it's moving into Northern California. That's about 18Z, but then high pressure comes in, sort of shuts things down again 180 hours out. High pressure starts building under the split in the jet in the West Pacific, and it sort of looks like this is the last bit of significant energy for the active phase of the MJO that's currently in play, but hopefully we're wrong, and hopefully this is more of just a pause than the end of it. So next we take a look at significant wave heights. This is the manifestation of winds on the ocean surface and what effect those winds have. Clearly we saw a fetch right in this area, created 30-foot seas, or is creating 30-foot seas, aimed reasonably well at Hawaii. Then another tiny low that we saw, or gale, up here in the western Gulf. A microscopic area of 30-foot seas, not particularly great at swell production. So the main fetch here, targeting Hawaii, goes into Monday night. Tuesday regenerates 32-foot seas. And then also notice another secondary little fetch here was at 34 or so, 36. Actually gets to 40 feet here on 18Z on Tuesday. Maybe that's good for a small push of 18-second period swell or so towards the U.S. West Coast. New system then on Tuesday night, as we saw earlier, pushing off of North Japan with, 36 or 37-foot seas. We just sort of roll this out, and there's just this continuous steady state of seas in the 24 to 30-foot range going on. We'll just roll through this. You can see much, and then here, right, you get 28-foot seas on Thursday afternoon aimed at the U.S. West Coast, more back here towards Hawaii. I mean, the short of it is there's swell coming for both the U.S. West Coast and Hawaii, but the question is, how big is it? It's not going to be monster, anything like previous systems that we've seen, because those were generated by storms that had seas in the 50-foot plus range, a lot of long period energy. We seem to be in a more of a slack pattern. All these seas, you get 20-foot seas, that's good for maybe, if a broad area 20-foot seas, that's 13-second period swell, and you get in the 24, 25-second range, maybe 14 or 15-second period, and that's what it looks like. You get into Sunday, then we saw a system developing right off California, possibly creating some rain, and again in the 26-foot seas range, but very local, probably sort of a stormy setup, and that's it. And then back to the west, things start really shutting down. So this looks like, at least for the immediate future, a pulse of swell energy, again, both for Hawaii and the U.S. West Coast, and after that, not a whole lot, so make the most of what you can get. And as a result, here is the projected wave heights for, let's say, Oahu, North Shore, in the 20, maybe 30-foot range, but also north winds here when it's at its peak, rolling through the week, slowly dribbling down, winds getting a little bit more favorable. You have some trades here about Thursday or so, and with the declining surf height, maybe that would be a good window. And again, trades in the weekend time frame, surf heights maybe in the 19-foot Hawaiian range, and light trades there. For Northern California, consistent surf in about the, let's say, 10 to 12-foot range early part of the week, Monday, slacking off into the 8 to 9, maybe 10-foot range. Winds sort of northwest most of the time, nothing offshore and clean, and then larger by the latter part of the week into the weekend, but also a sort of a light onshore flow, and then more wind come the latter part of next weekend. So plenty of surf, pick and choose your spots. And then San Diego, smaller surf in the 5-foot range, 4 to 5 feet, pretty much the bulk of the work week until you get towards the end of Friday and the weekend in the 8 to 9, maybe 10-foot range. But winds basically northwest 10 knots, probably not so favorable, all associated with probably a front that's going to come through and then high pressure building behind that. Let's look beyond El Nino 2015-2016, getting towards the end of the cycle, moving towards spring. Let's take a look at the details. First up, we'll take a look at winds in what we call the Kelvin wave generation area. Here's the date line here. We're talking just 2 or 3 degrees north or south of the equator, and mainly over in this area. In normal years, when there's lots of warm water here near New Guinea, westerly winds or westerly anomalies will take warm water here, push it off to the east in the form of a Kelvin wave. It'll take that warm water, actually push it down to depth, and it'll track to the east in a pocket, eventually hitting the Galapagos. It tracks right under the equator, just 2 or 3 degrees south or north of the equator. It erupts there near the Galapagos or into Ecuador, forms a warm pool here of warm surface water that then gets caught by the trades and moves into what they call the Nino 3.4 region between about 120 and 170 west, and that in turn positively enhances the jet stream in northern months, or in the North Pacific in winter months, and helps support the storm track. And that's exactly what we've had this winter. Unfortunately, we have not had the rain that one would normally expect, the increase in rain associated with classic El Nino. And again, we talked about that. That's because most of the warm water was here and not really close to Ecuador, or not so much south even of California. It was more from Hawaii and out in that region. Anyway, currently we see trades pretty strong over the northern Kelvin wave generation area, a bit of west winds, but mostly south of 5 south. Not so much good for generating Kelvin waves, but at this point, there's not a whole lot of exceptionally warm water in this area. It's all been transported to the east by 5 previous Kelvin waves that have been, that's how this El Nino got generated. And so even if we did have west winds, it wouldn't do a whole lot for Kelvin wave generation area, but west wind anomalies or west winds in this area would at least support the jet stream. So looking here, this is anomalies, differences from normal for this time of year. Here is the classic El Nino warm water signature, 2 degrees above normal, maybe 2.5 if you stretch it a little bit. The interesting part is that this warm water pool pretty much cut off somewhere around 20. It's made some inroads to the east now. It's rather late in the year, doesn't do a whole lot, but still, any little bit might be a help. We also see wind anomalies here, west wind anomalies, pretty brisk, but again, mainly in the very far southern end of the Kelvin wave generation area. Let's take a look at one other chart. Here's the hindcast view from the GFS model 18Z Sunday. Here's the actual Kelvin wave generation area. Its core here, 3 degrees north and south of the equator, but we go out to 5 degrees north or south. And you can see, a little pocket of west winds there, a little bit of west winds there, but mainly calm winds. Calm winds, for the most part, are the same as westerly anomalies. Here's your trades up here, and normally this fills this entire area, but it's certainly not doing that. So the net result is no winds at all. It's the same as a generalized push to the east, or the equivalent of west winds. And just taking a look what's been going on the past 4 or 5 days, Kelvin wave generation area roughly from here to here, and you can see west wind anomalies. This is up at 850 millibars, which is up about 4,400 feet in the air, but it's a good proxy for what's going on down at the surface. And as we scroll through this, you can see the west wind anomalies are displaced to the south. There's about the 5-degree line right there. And there's your Kelvin wave generation area, and that continues. So it's, there's west winds, but not really in the core of the Kelvin wave generation area. And here's another way, looking back from latter part of January. This is the whole planet stretched out on one chart. The area we're interested in, here's the date line running right down here. So just a couple, mainly from about here to about here, the whole way down the chart. Reds are west wind anomalies, and we see little patches here in early February. And then towards the middle part of February, good westerly wind burst, westerly anomalies, not necessarily westerly winds. And then it built to westerly, actual westerly winds down on the surface, a westerly wind burst. But again, the point being, we could have these west winds, but there's not a lot of warm water, so you're probably not going to get a Kelvin wave out of it. But this is what has been enhancing the jet stream and created a series of solid storms, swell-producing storms over the Dateline region north of Hawaii. It brought us the eddy. It also brought the Titans of Mavericks, and then, of course, just a continuous string of large surf. And the forecast for the next week is a continuation of the same. Westerly anomalies, if not west winds, right in the south end of the Kelvin wave generation area. So, supposedly this should help the jet stream. Interesting, though, how the wave model chart depicts towards the end of this that the jet stream kind of peels apart and the storm production sort of backs off. This is why we're saying we're not completely sure that we agree with the long-term run of the GFS with the jet splitting, or if it does split, it might be a short-lived event because all the dynamics here suggest that a rather healthy jet stream pattern should persist if one is going to believe the model this far out. Another way to sort of look or start looking at the state of the Madden-Julian oscillation, which is a periodic atmospheric oscillation, runs about 3 to 4 weeks on, 3 to 4 weeks off. The active phase tends to support westerly anomalies in the Kelvin wave generation area right here, and which of course helps support storm development. The inactive phase back here in the Indian Ocean definitely does not support that. It tends to suggest that the jet stream will split and steals energy from the jet, and therefore the storm pattern or storm track becomes less cohesive, and a lot of times you end up with, of course, the split jet. Here we go. Right here, the blues are air. So this is outgoing long wave radiation. The blues suggest where there is more cloud cover, and therefore one can infer westerly anomalies. The reds suggest more sunlight reflection off the ocean surface, meaning high pressure, meaning less cloud cover, and the inactive phase of the MJO. The statistic model suggests that the active phase of the MJO is to move east over the next 2 weeks, slowly back off, while the inactive phase moves into the West Pacific, and that would pretty much mean the end of the storm cycle for swell production. But also note, too, is as the MJO moves east, it would also support, this is the area north of where the active phase of the MJO is. Up here is where the core of storm production would be. And as it moves east, then the core of storm production would move east with it and theoretically bring weather into California. Now, the dynamic model suggests that the active phase of the MJO is also to fade, but not nearly as quick, and not move east as quick, and that the inactive phase would take its sweet time making it into the West Pacific. But either chart suggests about 2 weeks out, somewhere between 2 and 3 weeks, the demise of our really strong jet and the storm machine is going to start coming to fruition. And yet another way to look at this, these are what they call phase diagrams. You are looking down at the top of the world, and you move from, let's say, Indonesia across the dateline into the West Pacific, then over the Americas, into the Atlantic Ocean and Africa, and then back into the Indian Ocean. And this track here tracks where the active phase of the MJO has been, let's say on the 13th of February, 22nd of February. Here we are right now with the active phase on the dateline. The ECMF model suggests that the active phases continue to move east at a pretty good clip and into the Indian Ocean 2 weeks out, where the GEFS suggests that the active phase is also supposed to do the same, and the closer these dots are to the core here, the weaker it is. The GEFS is suggesting a slower eastward progression, and that's pretty much what we saw up in the previous chart. But at some point here, 10 to 12 days out, either chart, it sort of looks like the active phase of the MJO is going to be exiting the Pacific. This is our favorite chart here, of course, the CFS model. And again, it's like that other chart. Here's the dateline running right down the middle. Past history is at the bottom. The forecast is at the top. We're looking for west wind anomalies. Here was a big patch in the January timeframe associated with the active phase of the MJO and a major westerly wind burst, Kelvin wave number 4. Here's the Kelvin wave number 5, I'm sorry. Here is the current active phase of the MJO. We can just overlay the MJO here. Solid red lines are the active phase of the MJO. This suggests that we're just working our way now into the active phase, and that it's supposed to hold here on the date line into the mid-March time frame or so. And also notice this, so California is like roughly right here. Notice the active phase moving onshore, maybe about the 9th. So this would be the window when you'd expect to see some precipitation in California, somewhere in here between the 9th and the 19th roughly, let's say. Anyway, but after that, come about the third week in March, the inactive phase is supposed to set up, take over. Precipitation would probably back off. Notice west wind anomalies here in the red looking pretty strong on the dateline region start fading out. And then beyond that, sort of a muddled pattern. The models have suggested some sort of active phase somewhere in the April time frame, but they don't quite have a good handle on it yet. But I mean, it's pretty typical. 3 weeks on, or 3 weeks inactive, or here, 3 weeks active, 3 weeks inactive, 3 weeks active again. Not quite that regular. It varies and can go anywhere from 3 to 5 or 6 weeks depending on what's going on in the atmosphere. But you see a much less active pattern as we get later into the spring. Pretty typical El Nino winding down. There's no no warm water really left, and we'll get in that. So even if you do have westerly anomalies, not a lot of warm water to push off to the east. So a slow wind down. So we've talked about westerly winds pushing warm water normally in the West Pacific. Here's the West Pacific. Here's the East Pacific. This is the equator, 2 degrees north and south of the equator. We're looking at a profile at depth down 200 meters. We see warm water, normally that's all balled up here, and cold water all balled up here. We see warm water making good incursion. In fact, notice this, the 28-degree isotherm line has never been past 120 west right here. The entirety of this El Nino, it has finally made inroads into Ecuador. A very shallow layer here, just down, what is that, maybe 10 or 20 meters or so. But still, making inroads nonetheless, and still a good pocket of warm water out here trying to make it east of Hawaii. But it is the anomalies, differences in normal for this time of year that we're really interested in. Normally what we've been seeing is this very large pocket of warm water here in the 5-6 degree anomaly range, but that is slowly thinning out here. We got one little tiny pocket off of Ecuador of 4-degree anomalies. And still though, warm water, so if you have westerly winds here, they'll take whatever warm water's here, but this is pretty much normal temperature for the time of year. Trying to feed, if you have warmer water here and you get westerly winds, then it's all going to push it over here. But things are winding down now. This is the last part of Kelvin wave number 5. And what's really noticeable here is this right here, cooler than normal waters starting to make significant inroads into the East Pacific. At some point, this is just going to, once this pocket erupts to the surface here in the Galapagos Ecuador range and gets carried off by the trades, this guy's going to come in here. Cooler water will evolve, and that'll pretty much be the demise of El Nino. But we still think that's probably 2 months off, somewhere in that range. Too much might be a stretch, but a month at least. Here's the high-res view, a little bit older. It's from the 22nd here, but you still see a small pocket of, 5-degree anomalies right here and 4-degree anomalies, not quite reaching up to the surface. Also notice a little pocket of cooler water right here. This is the upwelling phase of Kelvin wave number 4 here, before Kelvin wave number 5 moves in. And of course, here's our cool waters as well. So pretty much they sync up well with each other. And this, the JSON-2 satellite data, strip out all the wind waves, strip out all the swell, strip out tides. This is his differences from normal in the height of the ocean surface. We still see a bit of a bulge here, 10 centimeter bulge a bit south of the equator. Here's the Galapagos here, datelines out here. So suggesting, since warm water at depth it actually expands, it creates a bump on the ocean surface, a bulge, and that's what this is measuring, suggesting there's still warm water at depth here. And this just basically is another way to verify what we saw in the previous charts. Also notice deeper than normal heights over here, suggesting cooler than normal water. That's because all the warm water's off in this region. And our favorite chart here, upper ocean heat anomalies, the upper 300 meters of the ocean surface. The reds are above normal temperatures, the blues below normal. Dateline is off in here somewhere, and basically we're going back in time. Kelvin wave, warm water, being pushed by westerly winds or westerly anomalies here in the far west Pacific, created one patch of warm water back in the March-April time frame. Kelvin wave number 1, Kelvin wave number 2 in June, massive Kelvin wave number 3 in the early fall time frame, yet a stronger one in the late fall time frame, and then Kelvin wave number 5 right here, and it's already pretty much as big as it's going to get and fading. And then here's the upwelling phase of the Kelvin wave cycle right here, working its way through the Galapagos and Ecuador right now. And notice cool water working its way in. And if we go back in time, notice that, see that cool water, it's made it to, what is that, about, let's say 155. There has been nothing like that all this year and all the year before that. So the end is near. This Kelvin wave here has muted the demise of El Nino, and it actually might help give us a soft landing. Typically, like the big El Nino of 97, 98, cool water came rushing in by the February time frame. Warm water was fading fast on the surface and subsurface, and we were in a rapid decline. And you sort of do this bounce back thing where you go much warmer than normal to much colder than normal, and you fall into La Nina. The thought is, maybe we're engineering ourselves here, setting ourselves up for a soft landing where we don't go into La Nina, but maybe we'll just sort of fall back into a normal pattern or a weak La Nina pattern, but nothing strong. That would be the best possible outcome from all this, and we'll talk a bit more about that in a minute. So we've talked about westerly wind anomalies taking warm water, and notice there's not a whole lot of it here. It's pretty much neutral, normal right now. Subsurface in the form of Kelvin waves pushes it to the east. Those Kelvin waves erupt in this area. They erupt to the surface. Trades carry warmer than normal water right into this area, the Nino 3.4 region right here to right here. Clearly we see that's the case. The interesting part about this image is that warm water, for the first time in months, not super warm, but is starting to make some progress here down into Peru, Ecuador, little pocket here of cooler waters, but there is some sense that maybe Kelvin wave number 5 is going to help push things a little bit more to the east. But the reality is we're late in the season. By the time it fully erupts, we're going to be almost out of the California rainy season. I don't know how much of a difference it's really going to make, but it's just an interesting tidbit. Otherwise, we still have a pretty respectable amount of warm water in this area, in the 2 to 2.5 degree range basically here, and that is positively affecting the jet stream, so good news there. And just a quick gander here, you can see the warmer temperatures here along Peru. These are, 2.25 degree pockets here. We haven't seen warm water like this in this area for 2 months or so. Now, the big bulk of the warm water was out here, out towards the dateline in south of Hawaii. That is actually declined rapidly. It's actually making a little bit of a comeback, nothing significant, basically. From a pure, like a super El Nino perspective, nothing significant here. But still, compared to cooler than normal water, we'll take it. It's good. It is positively enhancing the jet stream. And then the trend of the past 7 days, we're looking for yellows and oranges. We see pockets of warming, in the past 7 days, and actually it's gone out in this region a bit too, but that's backed off some. But over the whole, nothing significant in terms of giant warming or a strong warming signal, just sort of transitory pockets that show up and then disappear. And that's pretty normal considering where we are in the El Nino cycle. So it's great to have westerly wind anomalies because that, of course, feeds the jet stream. That is westerly wind anomalies in the Kelvin wave generation area. Also creates Kelvin waves. It is great to have warm water in the Nino 3.4 region because that also positively enhances the jet stream. Basically, the short of it, it creates thunderstorms on the equator, which then pump moisture and heat into the atmosphere, which helps fuel the jet stream. But at the end of the day, the best way to know whether El Nino is positively enhancing the storm track is to look at some indices that determine the coupling between the ocean and the atmosphere. Warm water in the ocean feeding atmospheric changes. The Southern Oscillation Index, differences in pressure between Darwin and Australia and Tahiti. Negative numbers, here's the daily numbers, suggest at least the active phase of the MJO. Prolonged negative numbers, like kind of what we're seeing here, suggest El Nino. The current daily index, down again, -40, attributable to low pressure in the Tahiti area. All-time low reached here for this El Nino event on February 22nd, -50.30. And of course, this in the middle of a strong pulse of the active phase of the MJO. 30-day running average gives you a sense of how strong the MJO is, and at -16.83, not too bad, and going to continue to dip for a little bit. I think we've been down at the -20 at the height of this El Nino event, so still pretty solid. And then the 90-day running average really tells you whether you're in El Nino or not. Clearly, we are down at -16.56 today. That's a pretty strong El Nino. The 30-day SOI average, you can see it since January 2014. Here's where we first started the El Nino pulse, false El Nino in 2014, but then in 2015, real El Nino, 30-day numbers down. Oh, here it was, -23 at one point, and then we went through an inactive phase. Here's an inactive phase, right? Here's an active pulse in late January, early February, then inactive, and now here's our current active phase. Again, we're dipping back down. We do not expect to get down to, what was this, almost -24. We'll probably get down around somewhere in here, and then it'll start heading back up. And then at some point, but you can draw a line pretty much here and go, you can see the trend just dipping negative, 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 probably bottomed out somewhere around here. And at some point, we expect to start seeing the trend heading upward as El Nino wraps up. It typically goes like this in the strong category for a year, and then it moderates, at least goes neutral, might go up into the La Nina range, or might muddle along in the neutral range, depending on what the Pacific Decadal Oscillation is doing. Another index, the ESPI, similar to the Southern Oscillation Index, only it's measuring actual rainfall in two regions, again, north of Darwin, right here, and then in the Nino, bigger than Nino 3.4 region, but right here, typically what you want to see is less than normal rainfall here, more than normal rainfall here. That sets the ESPI index positive. Current value as of today is 1.25. That's positive 1.25, which is actually pretty impressive considering where we are in the El Nino cycle. El Nino should be wrapping up, but still you can clearly see precipitation here attributable to the active phase of the MJO, warmer than normal water here, and a host of other factors. And also notice right here, rainfall developing more towards the Galapagos than it's been in quite a while. And again, it is where the rainfall and the storm centers are in the North Pacific Ocean is typically north of this area, so somewhere in here. This gives a little credence to the thought that maybe some rainfall will make its way into California in sometime near future. This, again, remains most interesting. Now here's time series ESPI data, and 2015, you can see it getting positive 3 in May, 3.8 in July, hanging in the 2 range, sort of backed off in November and then December, and here we are January, 2.3, again suggesting more rainfall or a greater difference in rainfall between Darwin and the Nino regions. And then now we can compare it to 97, and you can see 97 had 2.9. Here was a 3.0. muddled twos here, and then a 2.47 in January. We're at 2.3 something in January of this El Nino, and then it slowly faded off, and then it went negative as we fell into La Nina, but that index didn't change until the June time frame, until we went negative in June of 98. So we got a ways to go till we get there. And we talked a bit about the Pacific decadal oscillation, where it's going. So it's been negative or roughly in the negative range. We'll call it the inactive PDO, which supports long-running La Nina-like pattern. It's been in that mode till about somewhere in early 2014, and then into 2015, things got very positive, suggesting perhaps a long-term change. And so the PDO runs 15, 20, 30 years, one phase, and then flips, goes the other phase. We talked some about this last week. Go look at last week's video. We're waiting to see when the February numbers pop up. But again, right now it's positive, and it's been that way for the better part of 2 years. But El Nino's been in play, and a relatively strong one. And that can have some influence on the PDO. But what we really want to see is, as we get deep into 2016, to see the PDO stay positive. The thought is, if that actually occurs and we get a soft landing from this El Nino, that would lead us more credence that, maybe this El Nino wasn't the strongest of all strong El Ninos, but if it's helping to push us into a PDO run that's conducive to El Ninos, then we could go for 15 or 20 years here with more El Nino-like weather, stronger El Ninos, maybe more rainfall into California, and maybe part of this transition that we're going through, this drought sort of period, will be coming to a close. But again, that's very much of a reach at this point in time, but just something to consider looking out, not out a month or 2 months or 3 months, but out 2 or 3 years from now. Just something to monitor. So for now, series of storms, really gales, working their way through the western Gulf of Alaska and forecast to move closer to California a week out, possibly bringing precipitation, certainly bringing some degree of surf, not supersized surf, more normal human-sized surf, and then a little bit above that, probably in the 10-foot range and bigger depending on where you are. Possible weather for California. Looking beyond that, El Nino still holding together rather well. Jet stream looking pretty good for the immediate future, but a bit of a slowdown forecast a week or more out. Whether it will return and regroup, hard to say. Probably so. The MJO still active till well into March, and then after that, though, by the end of March, things are definitely supposed to start slowing down. And of course, then the long-term guess is, well, what's going to happen after El Nino? Clearly, it's wrapping up. Will we have a soft landing, or will we fall into La Nina? Unknown at this point in time. We'll keep monitoring. So, we'll do this again next week. Same time, same channel. Thanks for watching. Go get some waves, enjoy it, and be safe. Thank you.